Hello everyone, welcome back to our channel. Now in this video we are going to implement a sorting algorithm, that is topological sort. We use this for graphs, and where do you actually use it? We do it when the node has dependencies to cover first. That means the node that you're trying to traverse, right? There are dependent nodes which you want to traverse first. So whenever you have this kind of situation, right, then you want to go for topological sort. And the topological sort algorithm can only be applied for DAG, which is directly acyclic graph. Acyclic means without a cycle. So considering that background of topological sort, let's go ahead and implement that. We have some nodes and edges. Basically you have A node which is connected to B and C, okay, and in the end you have D node which is connected from B and C. The final structure, A is connected to B and C, and both of these B and C connected to D. So before you reach to D, right, you want to iterate through B and C first. So let's go ahead and implement that and test it. Okay, let's create the method of, okay. So once you're done implementing this topological sort method, it is supposed to return the list of strings, which will be the order of these nodes in the order we are sorting this. So that's why we are returning the list of strings. And now let's go for algorithm. So for each of the graph node in nodes dot values, basically for each and every node we want to iterate. So the first node that it will be getting, right, that will be A. So what do we want to do for each of the node? We want to create a method of topological sort which is going to take this node and it is going to take a set of visited node. Why? Because you need to track which nodes you already visited so you don't visit them again, and you need a stack for the iteration basically. Okay, this stack is going to hold all the values, and in the end we are going to get the sorted value from the stack only. So this is your recursive method. We haven't implemented that, that's fine. Now let's create these placeholders first for visited and stack. So your set of graph node is going to keep track of visited nodes, and you need to create a stack of graph node which you'll be using for traversal. Perfect. Now once you are done performing your topological sort algorithm, so we know it is going to have all the results in the stack. So how do you get the values from the stack? For that, let's create a output variable which is going to be the list of string. Let's call this a sorted list. Okay, now while your stack is not empty, what do you want to do? You want to add the elements to your sorted list. How? By popping the element from stack. And we are getting error because this is supposed to be a list of string, not nodes. So to get the string, we can take the label variable and we can return the sorted list from here. Now let's implement our recursive method. Now what do you need here? You have a node, you have a visited node, you have a stack. So first thing you're going to check the node that you're trying to visit, right? If you have already visited that node or not. If you already visited, you can return the control here itself. If you haven't visited, then you can add it to your visited set and mark it as visited. Perfect. Now once you mark it as visited, you want to traverse through all the neighbors of this particular node. How do you do that? Now for each of the neighbor which you are going to get from adjacency list dot get of this particular node, and what is the operation that you need to perform here? You need to call the topological sort on this neighbor. Okay, you can pass your visited set and the stack that you're using for traversal. And once this call is done for topological sort, you can add the node in the end that you're getting, the node that is yet to traverse, stack dot push this node, and that's it. With that line you are done with your topological sort algorithm. So let's go to the code again. What you did, you created a visited set, you created a stack, and for each of the node in all your node set, you are performing topological sort algorithm, which is going to give you the output in the stack. And how you're getting that output in the stack, you're checking if you're not visiting the same node again which you already visited. For each of the neighbor, okay, you're trying to visit the neighbor first in the adjacency list. So once you're done visiting neighbors, right, you are adding it to your stack, and adding to a stack only if it is not visited. That's how you're getting the output in the stack in a reverse manner. Okay. And in the main method call, what you're doing in the main method, in the stack variable, you are getting the list in a reverse order. So that's what you're doing here. You are removing the elements from the stack and you're adding it to a sorted list which you have created here, and in the end you are returning that sorted list. So that's how you are performing the topological sort algorithm. Now let's try running it. So I have told you, right, A is connected to B and C, and both B and C is connected to D, and this is where we have added the edges. So we should start with A, but before B and C we are not supposed to get D. First should be A, last should be D. In between B and C order can change. So let's run it and see what is the output we are getting. Okay, so we are getting A, B, C, D. That means our topological sort algorithm is working perfectly fine. We started with A, and then we have iterated or traversed to B and C before reaching out to D, which is our destination node. So that's how you implement your topological sort algorithm. See you in the next one.